All right, happy Friday, everyone. Let me fix my camera again so you can see me. All right, now we are there. Happy Friday, everyone. Today we talk about context caching and how you can actually make your Gemini input up to 4 times cheaper or 75% cost reduction. And I think you will be surprised how easy it actually is to use it. Just a few lines of code, very easy usage, and also a really good pricing model. So before we go into the code, maybe we talk a little bit about what is actually context caching. So context caching is designed to optimize the processing of your large context windows with generative models, in this case with Gemini. And it enables us the reuse of compute tokens across multiple requests. And this is done by basically reducing the need to recompute the input context. and we use it for subsequent requests. And this is particularly useful for extensive documents like a video, a large system prompt, maybe your code base you want to run your Gemini on, or if you have extensive in-context learning approach where you have a lot of examples for the model. For example, if you want to classify fruits or food on your table, maybe you have thousands examples, and for that, context caching could be very beneficial. There are a few benefits. Actually, there's only one benefit we have, and those are cost savings. By storing those compute tokens in memory, you actually only pay for the initial computation, and after that, you pay a smaller fee for storing the cached tokens rather than computing them from scratch every time. And actually, there is only one benefit, only the cost reduction. If you check the Google documentation, they also claim it's faster response times. I cannot confirm that at the moment, and you will see it later in the code when we run our code. We do some response time measurements, and I don't see any significant improvement there, but maybe it's on the roadmap. Let's see. All right. Before I go into the code, here's a small diagram on the screen here, where you can see how things actually work. So we have a cache on the right side. First thing we need to do, we need to create this cache. So we're sending multiple files to the cache, and then we are getting a cache ID back. And this cache ID we send together with our query, so the things we want to do, our initial prompt, together to our large language model, in our case Gemini, and then we are getting the answer back. All right, let's directly jump into the code, and you might hear it from my voice. I have a little cold, but I think it's still okay. So directly into the code. This is probably code you already saw if you used Gemini before. So we use a generative model. I'm using the Vertex AI SDK for that. And the only thing which we need in addition is caching. So we import this. I'm running the code. The code is as always on my GitHub repository, so you can check it out later if you would like to. Then we have the standard boilerplate code for the Vertex AI SDK. And here I have a small helper function to actually measure the time, how long it takes to get a response back from the model. So we are just counting the seconds it takes to get a response back. And before we use the cache, let's have a simple example without the cache. So we have something where we actually can compare the number, the response time it takes, and also see how many tokens we actually are processing. And for that, I have uploaded a small video, which I got from YouTube. It's about how to get started with Gemini on Vertex AI. It's an MP4 file, and we also have some system instructions here. So we're telling the model, you're an expert video analyzer, and you answer questions based on this video file, and always return Markdown. We have this, and if you're new to multimodal models, if we want to pass a video to a Gemini model, we need to load this. And for those we have those helper functions which are called part from URI. There are different helper functions available. We can have a look into that as well. And we send this together to our Gemini model. So first we load the model. I'm using Flash, the newest version. We pass our system instructions, and in the next step we generate the content based on our video and what we want to do based on this video. So we want a summarization of the video. As you see, this is an array. So we can actually pass multiple videos and multiple files directly with one response. So if you have multiple videos, or you want to cache multiple PDFs or your code base, you can send multiple files within this array directly to your large language model. So yeah, I need to run the cell before. So let's execute this and see how long it actually takes to process a video. And this can take up to a minute because depending on the image size. So this gives us some time to talk a little bit about the maybe limitations and functionalities we have with context caching. The very first thing you need is actually there's a minimum number of tokens you need to have before you can actually use caching. So your prompt, your context size needs to be at least 32,000 tokens large to use context caching. If you have a smaller context size, you currently cannot use caching. So it's from a specific amount of tokens, 32 tokens, 32,000 tokens to actually use it. And I think the cool thing, caching also supports function calling and, as you saw, system instructions. So you basically get all the functionalities you have with Gemini also directly with caching. And I think that's really cool. So you see it's now, we got the response back. We processed a little bit over 300,000 tokens, so over the minimum. And it took us approximately 40 seconds to process this. So this is now something you can take. You can look up the pricing for the Gemini model, and you see how much we actually paid for this. And with caching, now we're using caching. So we have basically the same like before. We have our system instructions. We have our video, which we want to process. And now the first thing we need to do, we need to create the cache. This is the first step. And for that, we call the module which we imported, caching, cache content, create. We provide the model, which is used for caching. We have our system instructions and our content, which in this case is this single video. And we can define time to live. The default are actually 60 minutes. So 1 hour is the default. Minimum is 1 minute, as far as I remember. And there is no maximum. So you could define a very, very large number here, and it will be kept in cache. Obviously depends a little bit on your use case. Sometimes we have customers, they do a prompt on a large context size once a day, once an hour. So they cache it before they actually run it to save the costs. But we have also other customers, they continuously cache it whenever there is a new request coming in. They cache it for 15 minutes. Until the next request comes, and then they create the cache again. Creating the cache, we can actually run this. You see, it also takes some time to create the cache. So you need to find a good trade-off of having the cache always up and running, or let it expire and create a new one, because as you see, it takes time. It's now taking the video, it's producing those pre-computed tokens, so it takes time. Almost the same time like before. Now we wait a little bit. What you can also do, there's a possibility to update the cache. So in case you see there's a new request coming in, you want to keep it for the next 15 minutes, you could also update the cache. But there's an update method where you can set in expiration time, and then it starts resetting with the new expiration time. Yeah, so now it is created, and we're getting a cache name, which is basically a ID identifier. That's what you have seen in the chart before. Let me share the chart again. So this one, this is basically the cache reference we have here on the left side. Now this is the ID we need to pass to the request itself. So you see, we can have a look into the cache details. You see the created time of the cache, we get the expiration time of the cache. It's really nice. You can actually see when it's expiring, and you see how many tokens the cache is actually using. In this case, text tokens, because we have our prompt, our system prompt, and you see we have tokens for our video, and you also see the video and audio in seconds, because we have a video with audio, so we have video and audio in seconds. This is important because the caching pricing depends on the file type. We can actually go to the pricing before we continue this example. So let's have a look into the pricing, how it works. This is the pricing for context caching, meaning this is the amount of dollars you need to pay as long as the cache is existing. And you see, for images and audio, it's based on the seconds. So it's really useful if you are creating the cache to actually get the amounts of seconds of your video. So it's easy for you to calculate the amount of costs you have per file stored, or video or text, whatever it is. So you need to do the calculations there. Here we have this. So this is the context caching pricing for storing the context. All right, and as you see, this is the price we have to pay if we want to process an image which is cached. And it's, as I said, 4 times cheaper compared to the normal Gemini pricing. All right, let's go back to the code again. And we actually run this as well. So now we are using our generative model, but instead of loading the model directly, we load the model from cache, so from cached content, and then we're providing the cache ID. This is how you use the cache. And let's see, previous one took us how many seconds? 41 seconds. No, this was the cache creation. So 43 seconds it took us. Let's see how long the cached version takes. As I said, it's about cost. It's not about the response times, at least not from my experience. As you see, it took even longer. So as I said, it's only about reducing your costs by a factor of 4. So now we are getting a response, and we can actually have a look into this, and we are getting a summarization of the video. This is basically already everything you need to know on how to use the cache. It's all about reducing your costs. One important thing you might ask, all right, how can I maybe load the audio, or are there different ways to load the different formats? So if we're looking into this part from URI, there are actually more functionalities available. So we can load from text directly, put something into the cache. You can have the helper functions from image, from URI. URI means from a Google Cloud Storage location, not from a web location, Google Cloud Storage location. And if you're using this, you need to provide a MIME type. And those MIME types, they're actually all documented in the Google documentation. So if you are heading over to the documentation, we have the MIME types for documents, which supports PDF and text. So those are the Gemini MIME types. For image, we get PNG, JPEG, and WebP. For videos, there's actually a bunch of the most common used video file types. And for audio, we get also a bunch of audio files. So those are all supported. If you have, for example, a Python file and you want to use it to cache your code base, you need to transform this Python file into a TXT file. So there are always workarounds, right? Let's go back to this example. You can also have a function response cached. I think this is really interesting. And there is also possibility for Edict and for client libraries, I think. All right, let's go back to the code. If you scroll down in the code, there's also an example on how you can use this with your code base. So I will shortly fly over it, but I'll not run it today. So the first thing we do, we take a GitHub repo, we clone this GitHub repo locally, and then we are iterating over all the files in the GitHub repo. And I'm only interested in the Python files, Jupyter notebooks, and Markdown files. We put them all together in one big code text. So imagine it like one big TXT file with all of our code base. And in the next step, we can actually cache this. So there's a tokenization. So my whole code base of my sample files is approximately 1 million token. We have the same. We are creating the cache. And this time I'm using it from text. So because it's in memory, I can run it directly from cache. And after that, I create my cache and I say, all right, provide me a summary of this repository. You could also tell the model to actually have a different demo. Let me open up the demo for you. Takes a few seconds to load. All right, this is a code-based analyzer, which is basically also using caching under the hood. What it's doing, it clones a GitHub repository, and then you can select your model, and you have different functionalities on what this model should do, like evaluate the code, create a troubleshooting guide, find the top 3 most severe issues in this code base. And this solution is also using caching, so you save yourself some costs because operating on a large code base is expensive. So you see, give me a summary of this code base and tell me the top 3 things that I can learn from it. And yeah, caching drastically reduced the costs actually for this application. Let's see till we're getting the first response back. This is also in the GitHub repository if you want to check this out. You'll see we're getting the top 3 things we can learn from it. So different services in this repository. All right, that's actually it is about context caching. Not too complicated, just a few lines of code. If you have a large context size, use it, save up to 4 times the costs. And yeah, I think that's for today. See you hopefully next Friday, maybe the week after. And I hope you enjoyed the session today. Have a good weekend.